Hey guys, welcome back to Tech Tips. Today we're going to be discussing some fire alarm applications and how to do troubleshooting on a NAC circuit. This method will be a little different than what I think most techs are taught, at least in my experience. So a typical NAC circuit, you have your fire alarm power supply, which is the most common way that most horn strobes get their power. You can also see this just right off the fire panel, but in any moderately good-sized system, the fire panel will simply trip one of these FCPSs and then things go from there. So if you get called out and there's a trouble on a horn strobe circuit, you're going to see a trouble on the FCPS. Usually there's just going to be a series of little lights on the side, and then each one represents one of your 4 NAC outputs. So you show up, you open this panel, and you see trouble light number 2, and you put your meter. First thing you're going to do when you walk up to a power supply that's got this an output trouble, you're going to put your meter right there on the output from that board, and you're going to check and see what the voltage is. First thing you do is always, what is the voltage? Because every NAC panel, every manufacturer, brand is going to have their own consistent voltage when the system is normal. When the system is intact and you have a resistor at the end of the line, you're going to see, we'll say 26.7 to 27 point something. There's going to be a couple of voltage difference, but they're all going to be in a certain range for that model and that manufacturer. Now, if circuit 2 is in trouble and you stick your meter on, you see 13.6. Well, that's a reduction of the voltage. It's much lower. Now, it's not a hard and fast rule that it's going to be cut in half. It could be cut by a third. It could be cut by much more. You might see 5 volts right there. But if the circuit is lower voltage, that usually indicates a short. So somewhere out there, there's a connection between these 2 wires, or it's crushed and the conductors are touching each other in the same cable, and then you get the voltage is unable to get to the end of the line. And so the panel will see the difference between an open or a short, and it will adjust that voltage. So as long as you know what voltage for that particular panel should be, then you're good. And first thing you do is you put your meter on the normal circuits, the circuits that are not in trouble, and then that tells you what you need to be looking for. So let's go the other direction. Let's say one of these wires just got knocked off completely and we're not getting a complete circuit all the way back. Well, then this circuit might go up to 29 volts, and we're going to see that voltage go up on an open circuit. And so here's where this becomes really a huge time saver and makes your troubleshooting so much easier, is when you go out in the field and you pull this horn strobe off the wall, you're going to see the wires on the back. You're going to stick your meter right on those wires while they're still hooked up, and you put your leads right there and you see, oh, look, there's 29 volts. Now you know you're on the open circuit. If you put your meter right there and you see 13 volts, you're on the circuit that's shorted. That's currently, you're on a different loop. So if you have a site where they don't have plans and it's multiple stories or there's multiple wings and you're trying to figure out which direction the wire runs, go out there, pull a horn strobe off the wall and check the voltage. You don't even have to pull the wires off. You can just meter it while it's still hooked up. And you see 26.7. Okay, well, this is circuit 1. You know this hallway is circuit number 1, or the NAC output of that power supply. And then you can mentally label it and maybe even put a label on that wire in the panel so they know which circuit goes where in the future, because you're probably going to be the one that's going to check it again, so it's going to save you time. But if you put your meter right there and you see 29 volts, oh, this is the open circuit. So now you can start looking for where that break is and try and reconnect it. Now, as soon as you fix the issue and you put your meter back on and you see this 29 went down to 26.8 or 27, then you know this is fixed. You do not have to go back to the panel and check and see if that trouble's gone. You know the trouble's already gone. This is what makes that method so great, is you can see the status of the circuit from the field side without having to go back and look at the power supply or look at the main panel, and you don't need a second person standing by at the front end. You can just see exactly what the status is from the voltage alone, and it's a huge time saver compared to yanking the wires off, separating the incoming and outgoing, checking for the end of line, seeing if you still want to check for end of line. It's still a part of the process to make sure the circuit's good going that direction, and then you check voltage going the other way and see if it's within the range that you want. Like if you pull these wires off between the head end and this strobe, and instead of seeing the 29 volts, because as soon as you lift the wires off, now it's an open circuit, so you should see a higher voltage. But if you still don't see the kind of voltage you want, okay, the problem's still back closer to the panel. It's not that direction, it's more this direction. But compared to checking for end-of-line resistance every single time, this is much faster, especially if you have horn strobe devices where the wires stay in a mounting plate and you're just popping the front of the face off. You can check it, snap it right back on. It takes you 20 seconds to figure out what circuit you're on, what the issue is, compared to, 2 minutes to yank the wires off, meter them, stick them back in, re-terminate them. This is just a really fun, quick method that has worked consistently for me, and I think it's the fastest and most effective way to troubleshoot any kind of a NAC circuit. You can also, of course, use this for other types of electrical work, but this is really effective in fire alarm. So that's all I got for today, guys. Thanks for watching, and we'll see you next time.